Class 10, Chapter 1, Real Numbers, Exercise 1.1, Question number 4. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. The hint given to us in the question says, let x be any positive integer, then it is of the form 3q, 3q plus 1 or 3q plus 2. Now square each of these and show that they can be rewritten in the form 3m or 3m plus 1. We will use the hint given in the question and take x as a positive integer. We will then take the three values of x, which are 3q, 3q plus 1 and 3q plus 2. Now we will find the squares of each of these values of x and show that the squares can be either of the form 3m or 3m plus 1. So let's take the first possibility of x, which is 3q. In this question, we need to find the form in which x square, which is the square of a positive integer, can be represented. So to find the square of x, we will square both sides of the equation, which will give us x square equals 3q whole square. 3q whole square can be further written as 9q square. Now we need to show that x square can be written in the form 3m or 3m plus 1. So we must prove that x square must contain at least one multiple of 3. So let's see how we can do it. From 9q square we will take out 3, which gives us x square equals 3 times 3q square. 3 times 3q square can be written in the form 3m if we prove that 3q square is an integer and we can write it as m. So let's see how we can say that 3q square is an integer. We will use the closure property of integers. In the question it was mentioned that q is some integer. So according to the closure property of integers, an integer when multiplied by an integer gives an integer. So q times q gives us q square, which is an integer. Now 3 is an integer, and when it is multiplied to an integer q square, it will give us 3q square, which is again an integer. So we can write 3q square as m, which is an integer, and x square can be written as 3m. So we have seen that x square can be written in one of the desired forms, which is 3m. Moving on to the next possibility of x, which is 3q plus 1. Again, we will square both sides of the equation to get x square equals 3q plus 1 whole square. Now, we will use the expansion formula a plus b whole square equals a square plus 2ab plus b square to expand 3q plus 1 whole square. Using the expansion formula, 3q plus 1 whole square can be written as 9q square plus 6q plus 1. Again, we have to show x square in one of the forms 3m or 3m plus 1. So how do we find 3m from 9q square plus 6q plus 1? In this expression, we can see the terms 9q square and 6q have 3 in common. So we will take 3 as common and write x square as 3 times 3q square plus 2q plus 1. Again, by the closure property of integers, 3q square plus 2q is an integer, which can be written as m. So we can represent x square as 3m plus 1. So we can say that for the value of x 3q plus 1, the square of x will be of the form 3m plus 1. Moving on to the next possibility of x, which is 3q plus 2, we will again square both sides of the equation and use the expansion formula a plus b whole square equals a square plus 2ab plus b square. We will expand 3q plus 2 whole square as 9q square plus 12q plus 4. Again, we have to show that x square is in one of the forms 3m or 3m plus 1. But from the equation x square equals 9q square plus 12q plus 4, we can see that 9q square and 12q have 3 in common, but 4 cannot be a multiple of 3. And we also cannot write x square as 3m plus 4. So how do we do this? We will divide 4 into 2 parts such that 4 can be written as 3 plus 1, and x square becomes 9q square plus 12q plus 3 plus 1. So what happens is that 9q square, 12q and 3 can be written as multiples of 3, and we have taken out 1. So x square can be further written as 3 times 3q square plus 4q plus 1 plus 1. Since integers are closed under addition, multiplication and subtraction, we know that 3q square plus 4q plus 1 will also be an integer. We can write it as m, and x square can be written as 3m plus 1. Therefore, we have proved that for any value of x, 3q, 3q plus 1 or 3q plus 2, the values of x square will always be 3m or 3m plus 1.